In this section, we are going to learn how to integrate rational functions. So rational functions are basically functions of the form px over qx, where p and q are both polynomials. So one very common technique we're going to use is called partial fractions. And the idea is that rational functions on their own can be difficult to integrate directly. However, partial fractions are usually much simpler to integrate. So let's have a look at an example. Let's look at example 13a. So in example 13a, we have this complicated proper fraction to integrate. And I mean, since it's a proper fraction, what we can do is that we can simply just write it in terms of try to write it in terms of its partial fraction. So we have a over x plus 1 plus b over 2x minus 1. Okay, and I'm not going to go through partial fractions in any detail. I think you have learned it before. Let me just give you a brief recap. Basically, what the first thing we're going to do is that we are going to try to remove the denominator. So we multiply throughout by x plus 1, 2x minus 1. So that will give us 1 on the left hand side, and on the right hand side we're going to get a times 2x plus 1 plus b times x plus 1. Okay, and here we can either do substitution and comparing coefficients to find the values of a and b. I prefer substitution, so you can just sub in x equals to half, b equals to minus 1. You will obtain the values a equals to minus 1/3, b equals to 2/3. So instead of integrating this fraction, this complicated fraction, we can deal with its partial fractions instead. And this is more convenient because, I mean, 1 over 3x plus 1, we recognize that this is basically something like ln x plus 1, and similarly for the second fraction. Okay, I'm going to leave you to check the details, but you should have no difficulty in checking that the integral reduces to, yeah, basically the answer. Let's move on to part B. So in part B, we are asked to integrate another proper fraction. So let's just write it down. This is going to be 1 over x plus 1 times x plus 2 squared. Okay, and as before, let's just try to write down its partial fraction. So this is going to be a over x plus 1 plus b over x plus 2 plus c over x plus 2 squared. So note that x plus 2 is a repeated factor. Okay, so what do we do from here? Of course, as before, we are going to multiply throughout by the denominator. So we are going to get 1 on the left hand side, and on the right hand side, we are going to get a times x plus 2 squared plus b times x plus 1 x plus 2. Oops, let me rewrite that. X plus 2 plus c times x plus 1. Okay, so again, you can substitute x equals to minus 2, x equals to minus 1, and then the last one you can just compare coefficients or sub in anything you like. You will be able to obtain, if you do it correctly, a equals to, I think it's 1, b equals to minus 1, c equals to minus 1. Okay, so for now, just take it as correct and check it on your own slowly at home. Okay, so once we have this partial fraction decomposition, the integral is simply, we can rewrite it as the integral of its partial fraction. So instead of integrating that monstrous thing, we're not just going to integrate 1 over x plus 1 dx minus, since b is minus 1, 1 over x plus 2 dx. Again, c is minus 1, so minus 1 over x plus 2 squared dx. I hope it's clear how to proceed from here. Basically, 1 over x plus 1, its integral is just ln of x plus 1. Similarly, integral of 1 over x plus 2, that's just ln of x plus 2. Okay, the third one is a bit trickier, but note that it's just x plus 2 to the power of minus 2. So this is just some power of x plus 2. But it's the power is minus 2, so this means that we can't use ln, so it's basically using the familiar rule, it's just x plus 2 to the power of minus 1. Okay, or this is of course the same thing as 1 over x plus 2. Let's move on to part C. So in part C, we have this fraction to integrate, and we notice that its denominator contains an irreducible quadratic factor. So x squared plus 1 is x squared plus 4 is irreducible because it can't be factorized any further. And so the corresponding partial fraction form is going to be bx plus c over x squared plus 4. I hope you remember all of these. Okay, so again, multiplying throughout by the denominator, we are going to obtain this equation over here, and by comparing coefficients of substitution, I'll leave you to check that indeed we get these three values of a, b, and c. So how do we then integrate this fraction? Okay, again, we are going to rewrite it in terms of its partial fractions. So this is going to be the integral of a over x plus 1, so it's 1 over x plus 1 plus bx plus c, so minus x plus 1 over x squared plus 4 dx. Okay, 1 over x plus 1, this is very straightforward to integrate. We know that it's basically just ln of x plus 1. The second one is a bit trickier, minus x plus 1 over x squared plus 4. So observe that if you differentiate x squared plus 4, what you're going to get is 2x. Okay, so I can kind of write the minus x as minus half times 2x. Let me just do that now. So what I'm saying is that I can write the first part as minus half times the integral of 2x over x squared plus 4. And then after this, I am still left with 1 over x squared plus 4. So I am still left with 1 over x squared plus 4. Okay, so how do we now integrate the middle expression? The middle expression is 2x over x squared plus 4. So the 2x, remember, it's kind of like my f prime x, and the x squared plus 4 is kind of like my fx. So it reduces to ln of fx or ln of x squared plus 4. Okay, now what about my last term, 1 over x squared plus 4? How do I integrate it? So observe that 1 over x squared plus 4, that's like your 1 over x squared plus a squared. And if you go back and look at the formula sheet or the table a few pages ago, you're going to recognize that I can integrate that by taking 1 over a, which is 1 over 2, since 4 is 2 squared, tangent inverse x over a, or x over 2 plus c, and we're done.